Hi everybody, welcome to Unit 6 Video 2. If you do not have your notes packet out, please go ahead and get it. We are on topic number 2. I can solve quadratic equations by using the quadratic formula. All right, so first we need to figure out what the quadratic formula is. And so we are going to derive the quadratic formula from the standard form of a quadratic, and we're going to derive it by using completing the square. So remember, the first step of completing the square is we need to subtract c from both sides. So then we're left with ax squared plus bx equals negative c. Then we can't complete the square until the coefficient of x squared is 1. So it means I need to divide everything by a. So then I'm going to be left with x squared plus b over a x. I'm going to put my blank spot equals negative c over a plus blank spot. All right, so now I need to go ahead and fill in the blanks. And remember, this is, I need to take half the coefficient of x. So b over a times 1/2 is plus b over 2a. And then I need to square that. So on the other side, I'm actually going to square it. So I'm going to get plus b squared over 4a squared. All right, so now on the left-hand side, I need to factor this. So this is going to factor into x plus b over 2a squared. On the right-hand side, I need to add these fractions together. So they need a common denominator, and the common denominator is 4a squared. So the right hand already has 4a squared. So the left-hand side, I'd have to multiply 4a to the numerator and the denominator, which would give me negative 4ac over 4a squared. So this is plus b squared over 4a squared. And so in my next step, I'm going to make this as one fraction, and I'm going to switch the order, because normally you're used to seeing it as b squared minus 4ac. So I'm going to rewrite this, x plus b over 2a squared equals b squared minus 4ac all over 4a squared. So then in order to get x by itself, I'm going to take the square root. So I'm going to go ahead and do my work up here. So I'm left with x plus b over 2a is equal to plus or minus. The numerator I can't simplify because this is a whole unit. It's a quantity together, and I can't take the square root of it. So I'm left with b squared minus 4ac. But in the denominator, I can take the square root of 4a squared, which is going to leave me with 2a. And then in order to isolate x, I'm going to subtract b over 2a from both sides. So then I'm left with x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And so then at this point, you can leave it as two separate, or if you want to write it as one, you can write it as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so then now here's my quadratic formula. So when I solve a quadratic like this, I don't need to complete the square. I can plug it in straight to the formula and get my roots, or get my, I can solve for x. So let's go ahead and try that. And so it says solve by using the quadratic formula, which we just solved, or which we just derived right here, and give the answers involving radicals in simplest radical form. Okay, so let's go ahead and see what we have here. Okay, so we want to start by identifying a, b, and c so that we can fill them into the formula. Remember, in standard form, you have ax squared plus bx plus c. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So I like to write them on the side here. So the coefficient of x squared is 1. The coefficient of x, or b in this case, is negative 5. And c, the constant, is a negative 14. So now that we have all of our values, we can go ahead and plug them into the formula. So we have x equals, we say negative b, so negative parentheses negative 5, plus or minus the square root of negative 5 squared minus 4 times a, which is 1, times c, which is negative 14, all over 2 times a, which is 1. So now that I've plugged it all in, I can go ahead and simplify. So I get x, this is going to give me 5 plus or minus negative, the quantity negative 5 squared, so 25 Negative 4 times 1 is negative 4, times a negative 14 is going to give me a positive 56. And then all over 2 times 1, which is 2. So then when I go ahead and simplify again, I'm going to do my inside my radical first. So I get x equals plus or minus the square root. So 25 plus 56 is going to give me 81 all over 2. So then I'm going to simplify. So 5 plus or minus the square root of 81, so 9 over 2. So then remember, when you're doing your math here, you do the numerator first and then divide it by 2. So you have 5 plus 9 over 2, so x equals, and x equals 5 minus 9 over 2. So here, 5 plus 9 is going to give you 14 divided by 2, which is going to give you x equals 7. So that's our first root. And then 5 minus 9 is negative 4 divided by 2. So x equals negative 2. So our parabola would cross at 7 and at negative 2. So there's our roots. All right, so I want you guys to pause the video and go ahead and try number 2. Okay, so let's go ahead and see how you did. So remember here, you want to simplify as much as possible. So 4 times 14. So 4 was a perfect square, so you could factor that out. And then here, you could take a 2 out of all of these terms. And so then your simplified version is negative 2 plus or minus rad 14 over 5. So, okay, so number 3, I want you to go ahead and pause the video and try to do number 3. All right, so for number 3, this one had an imaginary number underneath the radical, so we can go ahead and take out I. So we end up with 5 plus or minus I rad 23 over 8. All right, let's go ahead and go to the next problem. So now we get into our word problems. So our word problems here. And we're going to solve these using the quadratic formula. So we have the volume of a rectangular jewelry box, 4 centimeters in height, is 136 centimeters cubed. If the perimeter of the base is 24 centimeters, find the dimensions of the base. Okay, so we've got a couple of things here. We know the volume and we know something about the perimeter, okay? So the first thing I'm going to do is I'm going to just, in general, write those equations. Remember, perimeter equals 2L plus 2W, and the volume equals length times width times height. And so now that I know these things, I'm going to go ahead and substitute in what I know. So I know the volume is 136 centimeters cubed. So I can go ahead and plug that in here, 136. I also know something. I know that the height of the box is 4 centimeters. So I can go ahead and plug that in also. So I know the length times the width times 4. And then for the perimeter, it says if the perimeter of the base is 24 centimeters, find the dimensions of the base. Okay, so the perimeter is 24. So then I have 2L plus 2W. So I have the length and the width. All right, so what we want to go ahead and do is you can either isolate one of these variables and plug into this equation, or you can isolate one of these variables and plug into this equation. Now, you have to always choose whichever one is easier. This one is going to be easier because when I isolate either L or W, I'm going to end up with no fractions. Whereas if I did here, I could end up with a fraction, and it's easier to not work with fractions. So I'm going to, since I have to find both dimensions, it doesn't really matter. So I'm going to isolate for L. So I'm going to go ahead and subtract 2W from both sides. So I get 24 minus 2W equals 2L. Then I'm going to divide all the terms by 2. So I get 12 minus W equals L. So now that I have this, I can go ahead and take 12 minus W and substitute it in for L into my other equation. So then I get 136 equals 12 minus W times 4. And so if you'd rather rewrite this in a way that's more familiar to you, you can rewrite it as 136 equals 4W times 12 minus W. So I just took these two and moved them in front. All right, so now we need to go ahead and solve. So I'm going to distribute. So I get 136 equals 48W minus 4W squared. And so again, I want to go ahead and set it equal to 0. I want the w squared to be positive because it's just easier to work with positive numbers. So I'm going to move negative 4w squared over, and then I'm going to subtract 48w. So that's going to give me this 4w squared minus 48w plus 136 equals 0. All right, so now that I have all these numbers, I could go ahead and say A is 4, B is negative 48, and C is 136, but then I'm working with pretty big numbers. So since I can factor a 4 out of all of them, I want to go ahead and do that because it's going to make it a little bit simpler. So when I factor the 4 out, I'm left with w squared minus 12w plus 34 equals 0. All right, so now I'm going to go ahead over here and identify A equals 1, B equals negative 12, and C equals 34. So now that I have all of that, I can plug it into the quadratic. So I can say x equals negative 12 plus or minus the square roots negative 12 squared minus 4 times 1 times 34, all over 2 times 1. All right, so we're going to just go ahead and simplify. So we have 12 plus or minus 144 minus 136 over 2. So then we get x equals 12 plus or minus the square root of 8 over 2. And so then you're going to want to go ahead and simplify. And so here we're going to get x equals 12 plus or minus the square root of 8. You can simplify into 2 rad 2 over 2. And then you can factor a 2 out of all of these. So you get x is equal to 6 plus or minus rad 2. And so now that you have 6 plus or minus rad 2, since they're asking for the dimensions, you can go ahead and turn this into a variable. A decimal. So if you type into your calculator 6 plus rad 2 and then 6 minus rad 2, we can get approximate answers since they wanted the dimensions of length and width. So if you did 6 plus rad 2, then you're going to get 7.4, about 7.4. Or when you do 6 minus rad 2, you're going to get about 4.6. So to answer the questions, you can say, or to answer the question, the dimensions of the base are about, or you could say are approximately, I'm going to abbreviate, 4.6 centimeters by 7.4 centimeters. All right. Okay, so I want you to go ahead and try number 5. Remember, you have a couple things here, when they're talking about this rectangular field with an area of 5,000 meters squared is enclosed by 300 meters of fencing. Find the dimensions of the field. Okay, again, something about the area equation. And you're talking about this field that is enclosed. So if you're enclosing it, remember, you're finding the perimeter because you're enclosing the field. So go ahead and pause the video and set up the equation and see if you can solve it using the quadratic formula. Okay, so let's go ahead and take a look at what you got for number 5. So hopefully we got this. The dimensions are 50 meters by 100 meters. So I know they were kind of big numbers here, but then they went ahead and simplified. They were able to be subtracted from each other, and then you could simplify and then simplify again. All right, so let's go ahead and take a look at this last problem that we have here. And so we have a swimming pool 6 meters wide and 10 meters long is to be surrounded by a walkway of uniform width. The area of the walkway, the area of the walkway happens to equal the area of the pool. What is the width of the walkway? All right, so the area of the walkway, I'm going to write this out in words. Area of walkway equals area of the pool. Okay, so let's draw out what we have. So we have this swimming pool, So here's our swimming pool right here. This is our pool. Okay, and so the pool is surrounded by a walkway of uniform width. So it means that all the dimensions, my drawing is not to scale. Oops. There, that looks a little more uniform. Okay, so 6 meters wide and 10 meters long. So this is 6 by 10 here, okay? And the swimming pool is surrounded by a walkway of uniform width. That means from here to here, whatever the width is, from here to here, it's the same width. From here to here, again, the width is the same, and here to here, the width is the same. So the distance around, so the distance of the walkway, the width of the walkway is the same all around the pool. Okay, so then if we know that the area of the walkway is equal to the area of the pool, then let's go ahead and figure out what the area of the walkway would be. So the area of the walkway would be if you found this big rectangle and then you took out the pool. So that would give us just the area of the walkway. So that means we need to find the length and the width of your, or the width and the length of your walkway. So here we would have, we know this is 6, we know this side is W, this is W, so if we went all the way across, you would have 2W plus 6. And so then if we're doing the length of the pool, same thing, we have a W here, we have this length, and then a W here. So that means this is 2W plus 10. Okay, so the area of the walkway equals the area of the pool. And again, to find the area of the walkway, we would say area of walkway equals the area of the big, I'm going to say rectangle, minus the area of the small rectangle, which was also the pool, right? If you take out the pool. So if we set up this equation here, since these two are the same, area of walkway, that means you could just set these two equal together. Area of the pool equals the area of the big rectangle minus the small. So the area of the pool would be 6 by 10, because we know the dimensions are 6 by 10. And then if we do the area of the big rectangle minus the area of the small, so the outside would be 2W plus 6 times 2W plus 10 minus the area of the small one, or of the pool. That would be the smaller rectangle here. So you'd say minus 6 by 10. All right, so now that we've set it up, we can go ahead and solve. So here, if you want to try to do this, go ahead and distribute, see what you get, then solve it using the quadratic. So go ahead and pause the video and see what you get. Okay, so we got the width of the walkway is approximately 1.6 meters. So again, when we got to this point of our quadratic, you could factor out a 4 from each of them. Just to make it simpler, you could use 4, 32, and negative 60 into the quadratic formula. It's just bigger numbers to work with. And then when you get to this point, remember you're doing the quantity negative 8 plus rad 24, then divided by 2, and then you're doing negative 8 minus rad 124 divided by 2. And when you do that, you're going to get 1.6, and then you also get negative 9.6. Now, since this is the area of a walkway, you can't have a negative area, or sorry, the width of a walkway, you can't have a negative width. So since you can't have a negative width, the only acceptable answer is the positive 1.6. So 1.6 is our answer. All right, thank you for watching today's video.